Hello, my name is Tanish Bhatt. I'm a grade 9 student from Newfoundland, Labrador. My project is analyzing influenza vaccine effectiveness by aligning protein sequences of commonly circulating viruses and vaccine component strains. I became interested in this area of science 2 years ago when I contracted three different viruses all at once. It took me months to fully recover from the sickness. After the incident, I developed a keen interest in viruses, and I began to learn about influenza. I discovered that the effectiveness of influenza vaccines can vary over multiple seasons. I wanted to know why this would happen. So this project is understanding and evaluating the effectiveness of an influenza vaccine by comparing the main surface proteins of influenza, which are hemagglutinin (HA) and neuraminidase (NA) for virus strains to vaccine components. This was done for all influenza seasons in the past 2 decades. Results obtained were validated with the number of influenza cases in Canada. While obtaining the results, a difficulty I encountered was not knowing how to fully understand how to use the sequence alignment tool to carry out the experiment. It took me a month to familiarize myself with the program. To resolve this issue, I explored and researched how to use the program properly. My mentor gave me key insight and informational resources on how to conduct my research and my experiment. An example of this is when I was first executing my experiment. I would also note the query coverage between the two sequences. However, my mentor explained to me that query coverage was simply how identical the sequences are in length, and they have no influence, and it has no influence on how identical the proteins are. I executed this project by dividing it into three different phases: Phase 1, Phase 2, and Phase 3. In Phase 1, the commonly circulating virus strains and vaccine components were investigated by researching the Centers for Disease Control and Prevention's, or CDC's, past influenza season reports. The commonly circulating influenza A H1N1, A H3N2, and B viruses were researched. The unvaccinated strains were noted for further investigation as alignments in Phase 2. In Phase 2, I analyzed how identical the proteins were for each alignment. The HA and NA sequences were aligned using the National Center for Biotechnology Information's, or NCBI's, Basic Local Alignment Search Tool, also known as BLAST. The ideal result was that seasons with high percent identities would reflect fewer cases. Data was first graphed individually on a graph like the one on the left, and then that data was taken to make a graph on the right, which is a season summary graph. The season summary graphs would represent the total percent identity for each alignment in each season. The average HA and NA percent identity and the number of cases were analyzed on a graph similar to the one on the right. For Phase 3, seasons with excessive cases and high percent identities were further investigated for the reasons behind this occurrence. Additional research was conducted for this. After executing Phase 2, I observed that in the first decade, there are more commonly circulating virus strains, compared to the second decade. However, in the second decade, the circulating virus strains were shown to mutate more frequently. The results show that the higher percent identities reflected fewer cases and vice versa. There are two exceptions to this, however: the 2017-18 influenza season and the 2014-15 influenza seasons. After studying the causes behind this in Phase 3, I concluded that antigenic drift had occurred, which caused the results to be imprecise. The 2017-18 mutation was indirectly caused by the 2014-15 influenza season mutation. Overall, I enjoyed learning about virology and developing a strong understanding about influenza viruses and how protein sequencing works. My next steps for this project would be to determine if this process could be used to analyze the COVID-19 variant strains once more data is released. To explore possible methods, a procedure similar to my project would be used to do this. Thank you.